Look, mass spectrometry can used to find the molecular formula by measuring the mass. One, by finding the abundance of M and M plus one peaks, the number of carbon atoms, because there's C12 and C13. Then you can find how many uh, chlorine or bromine atom does each have by seeing the relative abundance of M plus 2M, because these are isotopes. Chlorine and bromine have isotopes. Then third, the most important finding of working out the structure of the molecule by finding the fragments. The fragments and their Me ratio help us identify the building blocks of that molecule. So what happens is when you hit a molecule by electrons, it will become into a molecular ion. Now this will have a structure. This will have a Me ratio, and it will be reported as a peak. It might like here this he's using all of them have a molecular mass of 70, nearly 70, and so even though there's a very small difference, you can identify which one of it is by mass spectrometry. So if it's very close, even for we can find, okay, if this is near 70, if it's 70.053, it must be this. If it is 70.078, it is this. And if it is 70.042, it is this. So what is the we can estimate the formula, we can find the molecular formula by knowing the approximate if you know the mass which are very close, you can mass spectrometry will identify what exactly is the mass. Then and the molecular formula. The other is by knowing the M plus 1 peak and M plus peak, because M plus 1 is because of the carbon, because it's got C12 and C13. The M plus 2 and M plus 4 is because of, you know, these are because of chlorine and bromine difference in the mass of the various isotopes. So M plus 2 and M plus 1 is basically because of that difference. There's a two difference here, and there is a two difference here. And once you know the how many chlorine, we can find the number of bromine. Like here, this is M plus 2, and because there's an 81 and a 79, and 79 you will have M plus 2, and you will have kind of 81 and 81, you will have M plus 4, and 79 will be just M. So we can find out by M and M plus 2 and M plus 4 peaks, the and also this relative and abundance will give us 1:1 ratio 3:2. It will help us identify what do we have. We have bromine or what. Like here, you can find the relative abundance A to B is 3:1, and four possible formulas, because if this will be the, and if the relative abundance is this, then it's C and D. So by relative abundance, we can find mass, the structure, molecular formula. But the most important is the fragment. Always remember, if there is a molecular formula, molecular ion, this is a molecular ion. See, this is plus and it's got lost an electron. It has lost an electron. It will cleave, and once it cleaves, the positive charge will convert to one ion and one free radical. The free radical won't be reported, and the molecular ion will be reported. So this is going to be reported. So we'll have a peak here and a peak here, depending if this is there will be two peaks in propanol. So that's why we have two peaks here, 43 and 15. While in propanol, you won't have at 15. Why? Because the cleavage doesn't allow in propanol. This is the formula, right? It's in is this, and propanol was this. There you could have this, so 15, but here you will have this. So depending on what is the structure, there will be a different peak. And always notice these two are too positive. It can't be too positive. One is a free radical that they are not showing. So when it breaks down, it will all break down into, like if this cleaves here, one will become positive. This will become a free radical. Otherwise, this will become positive. That will become free. He's just showing you the ions because these are the relevant. Free radicals don't show on the. Similarly here, if this breaks, this will be a ion and this will be a free radical, or this will be a free radical ion and this will be a, he's not showing you the free radicals. And if you have very close by, you're losing one free radical H and you're getting ions and you're getting these peaks here. So these peaks are representing one loss of one H. So you can make out the structure, and the most stable will be the most abundant, the base peak, highest abundance. And you can also find like whether by comparing these mass spectra of methanoid and ethanoid, why which one of this, what is the structure. If you have peaks here at 31 and 29, again he's showing you only the free radical ion here. No, he's not showing you the free radical here, but here he's showing you the free radical and the ion. And I don't know why he's not also showing you the free radical. He could also show you the ion of this. This ion doesn't form. I don't know why. Could be it doesn't form. So here it might not be forming. It's just forming, showing you this as a free radical. This won't show up here because it is not charged. And here this is the ethanoic acid. Both they have the same molecular formula. So, but here the peaks will be different. One cleavage here is calling this free radical, this ion. So 45 here. Another one is coming because of this CO breaking down, and it could be appearing as an ion. And here, this ion, this free radical is absent. So positive will lead to positive free radical. He's just showing you the free ion here. Could be the other free radicals he's not showing. And this is ion. The free radical is showing here, but this will not be appearing on the. So we can make out there will be a peak at 15 in the methyl methanoate. Now this is methyl methanoate. Yeah, this is methyl methanoate 29, 31, 15, 29. This one. This is methyl methanoate. And the 28, 43, 45. This 28, 43, 45. Only the ions are, don't see the free radicals. They will appear. So this way you can judge the structure.